Good morning, you guys. Yesterday we talked about an intro to inequalities, and so today we're really tying it in with the other things that we've learned as far as equations and stuff. And so we are doing one-step inequalities, and I put a smiley face because this makes me happy. Yay! All right. The reason why I kind of overloaded you guys on equations is because that same idea and those same concepts are still happening with inequalities. The answer tells us something different. It just doesn't tell us one number. It says this is either the highest number that it can be or this is the lowest number, and then everything else one way or another works. So understanding what you're getting is really important, and then understanding the steps to get there is also really important. So I'm going to go through a couple of examples, and I think you guys will do really well. Okay, so my first example is 25 is greater than or equal to v minus 2. A lot of people, when they see this inequality sign, they're like, oh no. But it's really not any different than if you were doing an equal sign. Okay, you want to keep in mind what it was. So I'm like above it, I'm going to put that it was that. All right. And then I'm just going to solve it like it was an equation. So I know I have to do the opposite operation to move something across that equal sign. So my v is being subtracted by 2, so I'm going to add 2. And because I add 2 to this side, I add 2 to this side. And then I have 27 is equal to v. Well, as soon as I get this, I can say, okay, 27 is equal to v. But that's not what I had to begin with. What I had to begin with was an inequality. So 27 is not equal to v. 27 is greater than or equal to v. And then that tells you exactly what's happening. If you want to switch it so we can do that trick, we would say, okay, v is less than or equal to 27. Remember, it's the same way. It means the same thing. It's just a different way of saying it. And then on a number line, if we have 27, we have 26, and we have 28, because there's this equal to sign with it, we close that circle. We're saying we're including 27. So 27 is equal or is less than or equal to 27. That's true, so we include it. Now we want to check a number either before it or above it, okay? So I would say 28. So is 28 less than or equal to 27? And it's not. So I don't shade that way. I shade this way, because if I substitute 26 in there, 26 is less than or equal to 27. And so I know that everything this way is going to make this inequality true. I don't care if it's 26, 25, 24, 23, 22, 21, so on and so forth, all the way to negative 100. It is less than or equal to 27. So that would make it true. Also, that trick that I showed you guys yesterday, as long as your variable is on the left-hand side, that arrow kind of shows you which way you're going. So that's one example. Let's do another one. We have x plus 3 is greater than 14. We're doing the same thing. Treat it like an equal to sign. If it makes more sense to you to plug an equal to sign in there, that's fine to begin with, but eventually you'll need to be able to work with it just like this, okay? So this is our equal to sign. I've boxed out my equal to sign before. You're welcome to box out an inequality sign. And then we're just isolating our variable. So right now we have x plus 3. Well, to get rid of a plus 3, we minus 3. So we minus 3 from this side. We have x is greater than 11, and that's my answer. I'm done. I don't need to flip it to get my variable on the left-hand side. It's already there. So on a number line, it would look like this: 11, 10, 12, because I know my number line. And then what you want to do is you want to check it. You want to say, okay, is 10 greater than 11? And it's not. 10 is not greater than 11. So I know it's going to be everything above 11 plus the trick works. I forgot to do my circle. So I have a circle on 11. Now, it's important to note that this one is open because I cannot include 11 in my solution, because 11 is not greater than 11. 11 is equal to 11. And because I don't include that equal to sign on the bottom, I cannot include 11 in my answer, so I keep that open circle. And that's the idea of one-step inequalities. I'm going to erase this, and I'll show you one that has to do with multiplying and dividing. And it's the same, I mean, we're doing the same thing, right? So if I have 3x is greater than or equal to 21, I'm still doing the opposite operation to isolate my variable. Right now it's timesing, so I will divide. So over here I will divide. This is really my equal to sign. It's my inequality sign. It's telling me what my answer means. So 3 divided by 3 is 1, so I just have 1x. Inequality, 27 divided by 3, or sorry, 21 divided by 3 is 7. And then I could graph that. I actually think you guys are just going to be asked to give this, which is totally fine. You guys will do well. Let me know if you have questions.